Our last section in Chapter 6 is 6.8. It's another application of exponential growth and decay models. So, when we talk about uninhibited growth of cells, a model that gives the number of cells in a culture after a time t has passed is n of t. Now, it's as a function notation. N of t, the number at time t, is equal to n sub 0, the number at time 0, the original amount, times e, there's that e, to the kt, where k is a positive number. N sub 0 is the initial amount. In other words, the amount at time 0, and k is a growth constant that represents the growth rate of the cells. So k will be a constant for each individual problem. Okay. This should remind you, so this is the time in the number in the future equals the number now times e to the kt. That should remind you of what we just saw with the financial models. The amount of dollars in the future was equal to the amount of dollars now times e to the rt. So the growth constant there was an interest rate. So this is really the same formula. Again, you don't have to memorize this for tests or quizzes, but it's the same formula. If you know this one, you really know this one. This one's written in function notation. This one is not. It's just because that's the way we do it in financial models. This is the way we do it in exponential growth and decay models. Okay, let's look at the first example. Find equations of uninhibited growth. So they're going to give us a colony of bacteria that grows according to the law of uninhibited growth. And here's the function. So we're going to break this function down and see what we have here and make sure we understand what we're doing. N is measured in grams and T is measured in days. Now here's a difference from the financial models. In financial models, T was always years. In uninhibited growth and decay, it can be anything from seconds to minutes to days to hours to years, whatever. You have to read the problem. Okay, determine the initial amount of bacteria. So if this is our function, what's the initial amount? N sub 0 is 100. It said it's measured in grams. What is the growth rate? Well, remember, the growth rate is the k. So k equals 0.045 or 4.5% as a decimal. What is the population after 5 days? In other words, find n of 5. So we put in 5 for t. And evaluate that, and you'll get 125.2 or approximately 125. How long will it take it to reach 140 grams? How long? They're asking us for t. So if we know that n of t is 140, so what is t when that happens? So we can plug that in. 140 is 100 times e to the 0.045 t. So here we have our exponential equation again. Get the exponential part by itself, divide both sides by 100. And now write it as a log. So our exponent, 0.045t, equals log base e, ln of 1.4. So t equals ln 1.4 over 0.045. And that's what, 7.5, and t was in days. What is the doubling time for the population? Okay, so it says we're going to double our original amount. Well, if you know the original amount, which we do, then we know that n of t would be 200 when we've doubled it. So what's t when that happens? Right? Get the exponential by itself, divide by 100. Write it as a log. Y equals log base A of x. So t equals the natural log of 2 over 0.045. So the doubling time is 15.4 days. Notice we said it would take 7.5 days to go from 100 to 140, so it makes sense that it would be longer to go from 100 to 200.